Hi guys, good morning or good day. My name is Jessa Baguio. For today's video, I'm going to share my learnings about the concept in this subject, BS Ed Math 8. And we all know that BS Ed Math 8 is all about the geometry, about the intersections of lines, about the hyperbolic, Euclidean, and everything. So, today I will share my learnings about this. So we all know that in mathematics, non-Euclidean geometry consists of two geometries based on axioms closely related to those that specify a Euclidean geometry. And I learned also in Euclidean geometry that the lines remain at a constant distance from each other, and these lines or those lines are also called a parallel lines. While in hyperbolic geometry, they curve away from each other, increasing in distance as one move further from one point of intersection with the common perpendicular. And these lines or katong lines na pagiyang gipasabot is mao to ang mga lines na are called a ultra parallel lines. In elliptic geometry, the lines curves toward each other and intersects. And also in this subject, BS Ed Math 8, it's all about geometry, diba? And also, we prove that the characteristics sa postulate of hyperbolic geometry na that the given point, dagan na lines ang mag-intersect niya. Dagan mo pass through sa given point. Pero ang sa given line never or wala jiga intersect sa given line, which is for example point C, dagan yung mag-points or dagan mag-pass through sa point C. Dagang parallel lines na mo pass through sa point C. Well, sa a given point, given line, or example, given line niya is line AB, never jud or wala jud nag-intersect sa given line, which is the AB. So mo na siya characteristic sa postulate sa hyperbolic geometry na atong na-prove. And also when it comes to the concept of ideal points and omega triangles, and also I've learned that in hyperbolic geometry, the two parallel lines do not have an ordinary point in common. But if imo gani siyang go through lantaw gani, nago na siya ideal point kanang two parallel lines, nago na siya ideal point sa pinakalas. Mo na siya ako nasabtan sa concept about the ideal point and omega triangle. And also, the development of the properties of parallel lines in hyperbolic geometry is continued by considering the omega triangle. And also, when it comes to quadrilaterals, we all know naman, diba? We all know that in quadrilateral, there are two kind of quadrilateral, which is the Lambert quadrilateral and the Sacheri quadrilateral. And what I've learned about the quadrilateral, or what I've learned about the two quadrilateral, that Lambert quadrilateral has three right angle. But the fourth angle of the Lambert quadrilateral is so called the acute angle. And naapo na tay prove na-prove po nato na ang kanang fourth angle sa Lambert quadrilateral is acute angle. Na siya theorem na imong masabtan, gihatagan kag concept about ngano ang fourth angle sa Lambert quadrilateral is acute. And also I've learned about the theorem when it comes to the sum of the measures of the angles of any convex quadrilateral is less than 2 pi, because we all know naman, diba, sa Lambert quadrilateral kay ang measures din na niya is less than 2 pi, or less than 360 degree. Oh, 360 degree. So less than 2 pi. So if imo siyang himuan og imaginary line ang lambert quadrilateral, so makasplit ka og duha ka triangle, and each triangle each triangle na imong na split is it measures also a less than 2 pi. So mo po na ako nasabtan about lambert quadrilateral kana iya mga measures. And also when it comes to sacharic quadrilateral, connected lang sila sa lambert quadrilateral because sacharic quadrilateral kana iyang summit sa sacharic quadrilateral is muna siya ang fourth angle sa lambert quadrilateral. So naa sila connection sa usa ang sacharic og lambert quadrilateral. So muna siya about sa mga quadrilateral, ilang mga triangles na proof po nato about ana. And also when it comes to Mobius, and I've learned about Mobius strip because nagipahimo man mi og kanang Mobius strip, a different design about a Mobius strip, and I've learned that about the Mobius strip na it is also called the twisted cylinder, is one-sided surface with no boundaries. It looks like infinite loop. And what I've learned in Mobius strip is daghang kang designs na mahimo, like naay may basic Mobius strips katong pag twist nimo is left and right, tas napa sa Mobius strip kay makahimo po kag heart designs. Muna siya ako mga learns about the geometry because and also kanapong, and also I've realized na in this subject there are a lot of theories that na ma-encounter jud nimo, and also mga proof, and dapat sabton jud nimo ang usa ka theory before ka mo go through sa sunod sa theory, because if you kana wala ka kasabot sa usa ka theory na imo dapat sabtan, is dili jud ka makaproceed sa usa ka theory because connected man ang mga theorem ana, and muna makaproof na ka sa imong theorem na ganahang sabton. Muna siya ako mga nasabtan sa concepts about the non-Euclidean geometry and Euclidean geometry. So muna to, thank you.